Hello to you all. You are welcome to this webinar today. This webinar is titled How to Model and Design Piled Raft Foundation with ProtaStructure Suite 2022. Our case study will be a foundation design of a multi-story building in Lagos, Nigeria. And this is because in Nigeria, Lagos is very prevalent when it comes to the use of piles and rafts. My name is Engineer Idu Opiku. I'm a civil engineer and I'm a gold partner of ProtaStructure in Nigeria. I'm also a licensed user of ProtaStructure Suite 2022. If you're in Nigeria, you can contact me through this email, edu.ofiku@protasoftware.com for discounts and flexible payment options. A valid license of ProtaStructure Suite 2022, or for any other inquiry you may want to make. In this presentation today, we are going to be looking at our outline, the overview of ProtaStructure Suite 2022. I'll talk briefly on the introduction to Raft and piled raft foundation, definition of some key terms that we may be coming across. Then we'll go to practical demonstration where we shall be dealing with general foundation setting, modeling and analysis of piled raft foundation, where the piles are evenly spaced. And this is because there are instances where the piles are not evenly spaced. And then we'll also look at the finite element foundation analysis and design, then creating of foundation reports if time permits, and also the conclusion. About ProtaStructure 2022. In summary, ProtaStructure Suite 2022 is a one-stop solution that combines all that structural engineers do when delivering projects into one seamless solution for building design and documentation. It models a physical structure, runs the analysis, carries out the design, produces detailed reports, drawings, materials, estimates, and you can also share through BIM technology with other team members. Is a all-in-one suite. One core advantage of ProtaStructure Suite over any other software is that the suite offers all necessary features in single suite. It's a software for streamlined modeling and analysis. With ProtaStructure Suite, you can model your structural elements, your building. You can also design, and then it's also a software where you do your detailing, drafting of component design. Then the card also, you can do your fabrication, steel designs, steel connection designs. Then the BIM, where you share with other leading software and also team members. Okay, so definitions. What is Raft foundation? A Raft foundation is a type of foundation that covers a large area under a building or extension. It is made of reinforced concrete and transfers the load of the structure evenly to the soil. It is also known as mud foundation. When should a Raft foundation be used? Raft foundation is constructed on weaker soils that are poor with respect to the bearing capacity. Like a place in Lagos, especially like islands, some of the areas it's very difficult to use conventional foundation, shallow foundation, pad foundations because the soil is not so good. You can also use raft foundations when columns are closely spaced and pad foundations may not be suited. It is also used when the load imposed by the superstructure is higher in magnitude. So there are kinds of structures that will necessarily require for you to use pad foundations. It is also used when the load imposed, yes, I've said that, and then when the water table is higher on the construction site too, raft foundation can be adopted. It is also preferred to avoid the shear failure of the structure due to uneven. Some key definitions, and please, I will encourage you to look at some specialist literatures on this, but I've been able to bring some points here. Subgrade coefficient is one term you are going to be needing. You need to understand the concept and what this is all about when you are dealing with raft and pied raft. So, what is soil subgrade coefficient? It could be called modulus or coefficient of subgrade reactions, which is defined as a pressure per unit deformation of the subgrade at specific pressures or deformation. You express it as a pressure over the expected settlement. It is used in determining the rigidity of the springs used for modeling the soil behavior. Basically, you can call it the spring stiffness, which is in kilonewton per meter square of ground. The coefficient of subgrade reaction is measured and expressed as load intensity per unit of displacement. So either way you want to define it, understand it, please, I will encourage you to check this out. Okay, the next term is a soil structure interaction. Soil structure interaction examines the behavior of soil with its interactions with structure in response to external loads. So this explains or demonstrates how the soil will react when you place a load on it. The load coming from a superstructure, it shows you. And in ProtaStructure, the feature can be assessed by selecting MED foundation model under soil structure interaction. The next thing here is pile capacity, which is very important whenever you are dealing with piles. Since we will be dealing with piles in these particular raft foundations, we need to understand what it is. And it is defined as a safe working compression load multiplied by the ultimate strength factor. We are going to be seeing all this when we start the practical demonstration. The ultimate strength factor is usually given in the geotechnical report. As an engineer, you might wish to use your discretion based on experience also to adjust the level, whatever level they are given. Then pile spring coefficient is the axial stiffness of the pile, and it depends on the ground conditions and the pile type. Let's proceed. Now, our project today, the design brief, I've tried to make the project simple since we don't have all the time and time of analysis, we need to shorten it. So the design brief, the foundation type, we say is pile draft, the location Lagos, Nigeria, the design code, relevant BS codes, or even Euro codes too. Then the pile type, boiled piles. Then the pile capacity, which is equal to the safe working load times, the safe working load. And then in this case, we'll be looking at it. Then pi spring coefficient, we are adopting 50 kilonewton per meter. Pi penetration depth, 100 mm. Please, these are usually determined for every project. But for the sake of this demonstration, we are going to be using the default value. Then we also have the pi termination depth of 12 meters. The pi diameter is 400 millimeters. Usually, all these are given from the geotechnical report. Then at 12 meters, the safe working load, which is here now, the safe working load is 240 kilonewton for this pi, meaning the pi capacity will be times 2, which is the factor of safety as recommended by the geotechnical engineer or from the soil report. So every project has this. It could be 2.5, it could be 1.5, but please note all these are determined from the soil investigation and the geotechnical report recommendation. And then the allowable bearing pressure at 0.5 to 1.5 in this particular instance is 19 kilonewton per meter square. You can see that this value is very, very low, very, very poor. And that is why we are now adopting pied raft. Concrete compressive strength is equal to 25 Newton per millimeter squared. Reinforcement tensile strength, 500 Newton per millimeter squared. So let's see in actions all the stories we have been talking about. We are going to be exploring the capabilities, those extraordinary capabilities, which are indeed are more or less revolutions in itself in structural engineering world today. And we are going to be looking. However, I want to run a disclaimer right now that please note that ProtaStructure suite is only a tool in your hands. I keep saying that because for every software, it is what you garbage in that you garbage out. It's a tool, and that this demonstration is only intended to guide and explore some of the software's capabilities. Hence, we cannot assume any liability whatsoever. So I encourage you to understand whatever you are doing. The decision is solely yours. As an engineer, you are responsible for your decisions. It is your responsibility to ensure that you have adequate technical capabilities to use the software correctly as per the reference documentation. Carry out the right modeling, review the result generated, and you will be good. Okay, from our practical demonstration, we are going to be switching over to the software. And when you open your ProtaStructure Suite 2022, the first thing you are going to see is a welcome page. And on this welcome page, I want to be very fast. The startup page, which will welcome you. You have information, open a project, you can see existing project, even this particular project today, you can see. Then you have new project where you can start a new project. Your user ID, you can see subscription details, the software status, whether it's up to date. Then the other resources you have, this will take you to some help that can get you started. Then you have also your videos here. Then from here, you have your ribbon. And that is one of the revolutions too. The ribbon have arranged all the tools in order of your design, where you first do all your settings, then you do your modeling, then you go ahead to do your loading, you review all you have done, do your analysis, carry out your design, you can see all your designs, go ahead to do your drawings and reports, then share information. If you so wish, you export to other BIM enabled applications, or even your DXF file. Then you can do display from here, your display setting, your view setting, and then the help, where you can see even your basic training guide, your Prota help about software, the authorization menu. You can also return your license to the server for another person to use if need be. Okay, so we'll go back to, I will close this, we'll go back to our project today. So this is the structural model, the multiple floors, uh, which you have. You can see we have done the superstructure, the staircases, all the designs, run all the designs. You can see your rooftop. I've done all this. So this is the superstructure. We are done with this, and then the next thing we have to do is to design our foundation. Mind you, the essence of, let me deactivate something. The essence of our analysis today, of this tutorial today, or should I say demonstration today, is for us to be able to demonstrate how you can design, you can model and design pied raft. So we'll go to foundation. For every foundation design, you must do what? After you complete your analysis, please, I've done this. I don't want you to enter. Okay, let's go ahead and do analysis. We'll carry out the building analysis, and depending on the type of model, I've also meshed some of the slab. So I'll go there and then see we run the analysis. Even though we have run this analysis before, please, how to model, carry out your modeling, and how to get to this stage. I encourage you to check out ProtaStructure tutorial on ProtaSoftware YouTube page. You can also follow them on LinkedIn, Prota Software. When you type it, you are going to see it on LinkedIn, on Facebook, on Instagram, and also other social media platforms, including Twitter. So we are running the analysis. So after your analysis, after running the analysis, even without carrying out your design, but it's expected, it's advisable you do all your designs to ensure that all your member sizings, they are all in order before you go ahead to run the foundation, so that you don't repeat. Assuming after running your analysis without carrying out your design, you come to the foundation and you discover that some of the members failed. Of course, when you increase any member size, you will also need to increase, rerun the analysis all over again. So I advise you to always ensure you are done with your design, before ensure that everything passes before commencing your foundation. But for the purpose of this analysis, of this demonstration, we are not going to be going into all that so that we don't get derailed. Check the YouTube page. You'll see a similar tutorial on how to model your superstructure. Tutorial that was carried out last year in May. So check it out and you will be good. So we are waiting for the analysis to be completed. This is taking time because I running the analysis with the slab mesh. So it's not just the building analysis. And that's because of the type of model that I have. So we are waiting. So while it's running, in this practical demonstration, we are going to be simplifying as much as possible. And meanwhile, you can try this software for 14 days free with all the capabilities and do everything. And I also encourage you to desist from using crack versions. Talk with us. We can discuss flexible payment options because we are interested in ensuring this software is made available to you as well. So please take advantage. We spread this between 4 to 6 months. And from the first installmental payment, you are giving the software to use. Okay, we are good. So the analysis is completed successfully and it took us 4 minutes, up to 4 minutes. Okay, so we close this now and we go ahead. So the first thing, after you've completed your analysis and like I encourage you, carry out your design. The next thing you can do, you can carry out your foundation setting. And these foundation settings can be done at any point in time. So you can carry out all your settings. But today, we shall be focusing on the foundation. So, okay, let's check the codes. Say BS, relevant BS code, done fine. And Euro codes is good enough too. So we go to our foundation. So from the foundations, from the soil report, most of this data are gotten from the soil report. So please, I encourage you to do what? Ensure you do the right thing. For every project, you must carry out the report. So the next thing from here, we have the soil unit weight based on the soil report or the geotechnical investigation. We have is 18 kilonewton per meter cube. You are seeing it now because, of course, I've run this before. So we can put this as our ultimate strength factor, which I had explained during our brief, and then the allowable stress of the soil. And you get to discover that this may not even be important for us too, but we are going to leave it here. Then the soil vertical subgrade coefficient, and these are usually calculated, but you can also get some values there based on the reference foundation analysis and design. Joseph Ibos, I hope I pronounced that well, 1995, table 92, who has recommended this particular value. And from here, you can pick the appropriate values. I'm going to leave this as 16,000 kilonewton per meter cube. The lean concrete, what some of us call as blinding, we are leaving it at 100 millimeters. Then the strip, we may not bother ourselves so much with this because we are not doing strip. Then I say display this, you can leave. So after setting all the appropriate days, based on your engineering know-how, your experience, the right thing, please ensure you what? You select input the correct thing. Whatever you put here will determine the final result. So from the minimum reinforcement setting, we are starting from 10 to 25. This may not get to this. Then that's the general setting. Pie caps. You also see the pie shaft. You can either choose if it's square or circular. In this case, it's circular. The ultimate strength. We'll still have opportunity to input this ultimate compression capacity. So you may still want to go ahead. 75 is the penetration depth. When we continue, we are going to see the penetration depth is the depth of the pie into the pie cap. Then our pie size, of course, all these are defaults, which we are going to be changing afterwards. So we may not need to waste our time here because whatever you choose there might just be the starting point for you. After design, you may need to change whatever you have the opportunity to change. Okay, so the report table, add columns, this, all this, we will have opportunity to come back to them. The pile two, steel area, tolerance, and all these are code based. So let's go back so that we don't waste much time. Let's get into action. So after carrying out your foundation setting, let's also look at the material setting. And this, you can always come back to this at any point in time where we can set our concrete values. Here we set the comprehensive strength is 25 Newton per millimeter square, which is C20 slash C25. The C20 here is cylindrical strength, but based on BS code and Nigeria, we use more of characteristic compressive strength. Taking my time to explain all this because I want us to be good. I don't want you to do guesswork. So when we get here, we are selecting 500, which is what our design brief has given us. This is solely on decisions and the availability of the materials. Nigeria will use between 410 and also 500. Okay, so after selecting this, we can also go and select our rebar sizes. I'm going to leave all this. You can choose any of these, like for your foundation slab, for slab, this is what will apply. Let me deactivate Y8. I'm going to start from Y10, Y10, Y12, Y16, and this will be for the design of our raft. Let's go on. Okay. So when you click, when you are done with this setting, The next thing you have to set, for you to do any foundation work, you must set the current story to foundation story, which is usually story 00. And then please, we are going to, I'm going to story 00 and then the plan view. Then the next thing we will do is to model. Let me deactivate this as well, so that you won't be wondering why it is not there. We'll go to visual interrogation. We'll come back to this later. Then we'll go to visual interrogation and we'll say no, put it to none. We'll come back. Okay, so you are going to be, you have to model your foundation. How do you want your slab to be? And let me take some time because we are not going to cover it here within the scope of this tutorial today. But you can either do ProtaStructure allows you to do just one full foundation slab. You can do one full slab, but oftentimes that one full slab may not be economical. So you may want to do what? You may want to slice or use something like strip along the under the columns, or you use your any of the insertion method, slab insertion method, to insert your slab. For instance, we can model this slab and then come here to insert all the slab here. We can come here, insert, and then we are good. But that is not the approach I want us to use today. So, but you can also do this. Is permitted. So what we are going to use today is to, which I normally use and which I encourage you, is to use external referencing. I've already prepared a layout of the foundation, and then you click, it takes you to the file. You can see takes you to, okay, take us to the file location, today's file, and when you see foundation layout. So that's because I've prepared it before. So I'm going to cancel it. Okay, let's go back to it. No need to cancel, so that you also see how I went about it. So when you insert, remember you can use color or remove it. Remember to use the appropriate scale factor, and then also we can make it active by either clicking this just the same way. But the location of this foundation, when you see, is not aligning. So if you bring this here, we might have problem. So what do? We have to move it to ensure that the coordinates are the same thing. So we are going to look at, from the drawing, we have E, this E. Okay, let me deactivate the color so that it will look different from what we have. Okay, so you can see it's now the underlay, our gray. See why? This is from the GXF file. So we come here now to select, we go here, say move, click move, select the intersection, use a reference point, which is E1, and then we'll move it to the E1 of the drawing. You must not use E1, you can use any other coordinates. Then we'll click OK. When you have OK, this makes This makes the modeling of the foundation to be very, very easy. So the next thing we'll do is to go to the slab. We'll select slab, and leaving it here, we can use any of this insertion method, like I explained earlier, to begin to fill up all this slab. But I am going to also use another very powerful function called slab and column edge, which is one of the very useful tool you can use to model any shape of slab and even column. But I wouldn't go into this. Please check the YouTube page as I explained earlier, and you will get these tutorials on how to go about this. But today we are going to be using polyline, and then this is my foundation line, and it doesn't matter what you start with. Sorry, I'll undo. Doesn't matter what you start with, but experience will help you to select the right shape. But whatever foundation you want to use, after running your analysis, you'll be able to tell whether it passes or not, and that will inform your decision. So all I need to do is to trace the line of my slab. To create the slab edge, this is my slab edge, which I've already prepared. So with this slab edge, I'll go ahead to my slab and leaving it on slab 1. And you can see this F here means it's on foundation. So leaving it on slab type 1, I'm going to start with 300. This is a practical thing. I don't want a situation whereby I must have predetermined this. Please let me delete what I inserted before. Okay, to ensure there's no slab here. So come here, I'll start with 300, and then we can say pick close. Even if you use slab, the beam region, it can give you that slab. But sometimes other axes, or maybe where you have other things that are interfering with this happening, the other thing you can do, we undo this. The other way you can go about it is to select the 300 and click pick close, then you select the slab edge. You see that it is very, very easy. Let's view what we have done. I'll save it. So this becomes our Raft foundation. So assuming you are just dealing with Raft foundation, which is called flat plates, you can see flat plates. This type of Raft foundation is called flat plates or mat foundations. No beam, it's just slab. Assuming this is what we want to do, we can do, but ours is pied Raft. So the next thing we do is to go ahead to select the Raft. Now, before we proceed, let's look at our analysis again. We'll go here to see our post analysis. No, here, Asia. We need to have an idea of what the load coming from the superstructure, what it is, to be able to help us with the number of piles you want to start with. So from here, you can see what we have. So if you add all this, you have an idea of where we are going. So let's go back. So the next thing we'll do is to click on the slab, select the slab. Now it's a single slab. If you have multiple slabs, you can select multiple slabs by holding down your control key and select the slab as you may want it. So, but in this case, since it's a single slab, we select the slab and then select slab, then we right click. The moment you select slab and right click, you see the option to insert pile is there. Let's look at it again. Select the option to insert is there, then right click, insert. So when you say insert, you will see that it will ask you to pick the pile reference point. So you may want to pick a reference point where you want to insert, make reference to. So here we'll pick A1. You can pick any other reference based on your judgment. In this case, we pick A1. The moment you click, the pile properties dialog box will open. And here we are going to be putting our diameter, which from the design brief, our diameter is what? From the design brief, our diameter, we say is 400. Can start from 300, but for want of time, you can start yours with 300, even 150, if it works for you. But usually from the geotechnical report, the range of piles you have to use are specified. It can tell you that, oh, this is the safe working load, the pile capacity of 300 millimeter pile. They give you the pile capacity 100, 600, 900, 1.2. So it's up to you to select, to use the appropriate based on your engineering judgment. And don't forget the constructability of whatever decision you are making. So would you want this kind of project? Would you want to select 600 millimeter piles? It's up to you to decide. So now the pile penetration, remember from the design brief, we say 75 millimeters. The pile length, we say is 12 millimeters, 12,000, that's 12 meters. Then the spring coefficient, we also told you. Then from the edges of the slab, you can specify the minimum distance. We can say, okay, from the edges of the slab, oh, maybe, let's say we are saying 200, or 150. And this you can, from time to time, you can always change. Now, the next thing too, you will see is that the eccentricity, which can help you to change the location of the piles at any point in time. If you want to move, you can always change the value here, but in this case, you are going to be leaving it at 0. Okay, we'll do one small calculation. From our load, let's look at calculation. Let's say our approximate load is 33,000 kilonewton, and we are looking at a pile capacity of 240 by the factor of safety 2. So we are looking at a pile that we have ultimate capacity of 480. So how many pies are going to be able to counter the load that is coming from the superstructure? Let's check the load again, and we can check our axial load comparison report by clicking on this. It's opening. This is immaterial because at the end of the day, whether it goes through or not, you are going to see. So we are looking at 30, let's say approximately 33,000. This is just for us to start. Let me also deactivate. It has finished its work. It was just for me to be able to trace. And please don't ignore this yield line. Whenever you are doing a flat plate, a raft or finite element, you have to ignore. Doesn't matter. So we'll go back from our calculator. Oh, let's check our calculator again. So if we have 33,000 divided by 480, so we are looking at about 68, right? Now, if you check the entire area of this slab and then you divide by 68, what will be the spacing? So we are going to now be selecting, starting with spacing, which you can always, this is just a guide, please. It's just a guide. I am sure you know what to do. So we check what we have here again. We say minimum distance 200. So we are going to put 1.2, 1,200 by 1,200. Whatever I'm doing now was not predetermined because I want us to go through the process so that even whatever we have fails, you also know how you can correct. And here you can make this. Please watch the background. You can see it can be hexagonal or rectangular arrangement. So in this case, we have arrangement. I explained this before, the minimum distance from the edge of the slab. And this may be very important because of your punching shear check. So the compression, which in brackets is your pi, they say pi safe working load for vertical combination, which will be factored using, so what do we put here? What we have is 240 as our pi safe working load. So it's not the pi capacity. The pi capacity will be multiplied by 2, but it's the software that will do that multiplication. And this 2 was, you remember when we put the 2 during our foundation setting, when we were doing our foundation setting. So the 2 will appear here. If for any reason you want to change this, then you have to cancel again and go back. I am taking my time because this is very crucial. You go back to change this, the ultimate strength factor. If I put 1.2 here, for instance, and we go back and we say insert, and we select, is 1.2 that will appear. But in this particular exercise, and like I told you before, this is usually determined from the geotechnical report. This is foundation. So most of the values you put here is usually from the geotechnical report. ProtaStructure is not liable, is not responsible if you don't put the correct values in all of these dialog boxes. So if you don't input the correct factor or values, you will not get the right result. So let's go back 200, and then we say it's 240. Click OK. So it's inserting our piles. Very good. So our piles have been inserted, and you can see the pile numbers because at the site during constructions, references are made to pile numbers. So ProtaStructure can also give you the pile numbers. Okay. Now, after you have inserted your piles, you want, let me demonstrate something quickly. You can select any of the pile, right click the pile, select properties. The properties of the pile will come up. This eccentricity now, you can see this pile 60. The eccentricity is the distance from our reference when we're inserting the pile. If you want to move this, let's demonstrate. Let's see. When you change this, you can see it will move the position. Let's see, 2200. You can see. So if you click OK, it has changed the position. So even when you want to stagger your piles, or after your analysis, you see that some are failing. We are going to demonstrate that too. You may want to shift the position of your piles. That is how to go about it. So if you select properties, we'll go back. See, please, let's undo this. After completing all your modeling and inserting your piles, the next stage is to analyze, go to FE, the finite element analysis, foundation analysis, and always ensure you are on level 00. And we'll go to analysis tab. When you're on level 00, the flow analysis will be deactivated. Only the foundation analysis, FE foundation analysis, will be active. So let's check something. When you change, if you are not in 0, you can see. So, but this will not be correct. You should always be on level 00 in order to do all your foundation analysis. And for just the benefit of those who might be asking questions, as at the moment, you may not be able to do a step when you are dealing with Raft foundation. It has to be on the same level for now. Okay. When you are done modeling your slab, your flat slab, and then inserted, when you are done inserting your piles, the next stage is to run your foundation analysis. And like I said before, you must always be on story 00. And for now, ProtaStructure Suite 2022 can only model a one-level foundation as far as Raft foundation is concerned. For pad, you can do step foundation, but for Raft, no. So we'll not go to analysis lab, select your foundation, finite element foundation analysis. And from here, we can use the subgrade reaction values, which will enable you to enable the software to use the individual slab partitions. But in this case, is a uniform subgrade coefficient. Then the next thing we can say, okay, include the column section in the FE model, but we are not going to do this now. We can also consider torsion stiffness. Ignore, and this is very important, because what you do to this, whether you are selecting it or not, will go a long way to affect analysis. When you say ignore bearing capacity, it means that the Raft, if you ignore this, it means that whatever soil subgrade coefficient you want to use now will be ignored, meaning the slab will begin to act as a pie cap. It's still Raft, but as a pie cap, the load will now be fully supported by the piles. So it means that it's completely supported by the piles with no contribution from the soil. And this will make the Raft to function as pie cap. So if the option is unchecked, it means that the horizontal pile forces will be lower compared to when the Raft sits on the soil. So if you ignore this, it means that bearing capacity of 19 kilonewton per millimeter square will be used. So the Raft will share part of the load with the Raft with the piles. So, but oftentimes, especially when the foundation, the bearing capacity is very low, what you do oftentimes is to ignore. And this will help you. So this is like erring on the side of safety. But it's all down to you to make your decision as an engineer. Whatever you tell the software to do is what it will do for you. You get your decision wrong, it will be wrong. So in this instance, we are going to ignore it. Okay. So the next thing, okay, let me explain something too. That when you have mixed piles with pads, sometimes you might have a structure whereby, whereas you are also modeling Raft, pile Raft, you are also introducing a Raft, a pad or pads foundation. You cannot use ignore soil bearing capacity. You must uncheck this. If you don't do that, what it means is that you might not be able to have anything reasonable, and it could result to error. I want to believe that this is understood, and if you need any further explanation, please don't hesitate to write to Global Support or also contact me, and I will be able to explain myself. So in this case, we are going to ignore. Then you can also apply the life load reduction if you want, which will not be used there. You can also decide to display analytical method, this analytical model before analysis. The sparse solver will help the analysis, especially if the analysis is complex. So here we run our floor mesh. This is the size of your plate, and the range, the recommended range is between 500 to 1000. The smaller this is, the slower will be our output. So the next thing is to mesh to run our foundation analysis. Okay, so we have succeeded in running our analysis, and from what you can see, all this on red, you can see the spring. So this can enable you and see these are all the loads from the superstructure, like where we have the shell wall. Okay, so you can also review all this, check your soil pressure. But in this case, we don't have soil pressure because we have ignored the soil pressure. So when you are satisfied with this, you click OK to continue your analysis. Foundation being updated from the FV analysis, click OK. When you do this, the forces are automatically updated from the superstructure. So now the analysis is completed. The allowable stress will put the allowable stress of soil, but since we are ignoring this, it may not really be necessary. Now let's check our pile report, because that is why we are here. On the pile report, you can create the summary, include load case and all this. For want of time, let's do the summary to see whether our piles will pass or not. Very good. Now from the pile report, you can see because the axial force imposed on the piles is more than the acceptable. This is the safe. This is the pile capacity, which is safe working load by 2 multiplied by 2. Because of this, the axial force on this particular pile number 1, because it's greater and it's negative, means it's in compression quite okay. Sorry, because it's greater, when it's negative, it's in compression. When it's positive, it's in tension. Of course, when it's positive, you know that we allow 15 kilonewton tension capacity. When it's positive and is more than this 15, it will also fail. But in this case, it's more. So this will give you an understanding. You may either want to shift your pile or increase the size of the capacity of the site, which means increasing the size of the pile. Or the other thing you can as well do, like when you go further here, you will see this particular one. The difference is quite much. You may want to leave it like this or optimize. ProtaStructure 2022 has made this very, very easy for you. So you can at the same time optimize it to say, okay, no, the gap between this and this is much. Maybe instead of using the 400 diameter, you may want to use 300, try 300 and see. And with the software, you can even revert back to this. So after taking all this and you are satisfied, because we are not going to be doing it for want of time, we are not going to be reviewing anything. But I have shown you what you can do. For instance, like this is almost 2 times the value of the capacity, meaning is either we are increasing the raft or we are increasing the size or we are shifting the position. There are so many things you can do, and you are at liberty. And ProtaStructure 2022 provides you that flexibility to want to make your adjustment anytime within the very short time. So even this one too, you can see. Not, this one is just telling you warning 470 to 480, even though it has passed technically, but it's too close to the value. So this amber sign you are seeing is telling you that what you have there as what is very close to the threshold. So you might want to use your judgment, might want to say no problem and move ahead. So when you are done, you now open your, you can click open your analytical model to now view your foundation. And this also, you can access this analytical model even from your analysis here, analysis tab, and click here and bring it out. You can see. So, but here, since you are in post-analysis processes and reports, we are going to continue. So, click on the display to review whatever you have done. If you are not satisfied with the report, maybe you want to see everything in perspective to see where you are. Now, I want to repeat again. You can see when you see the pie, when the pile is green, that means it has passed. When it is what? When it is red, it has failed. When it is amber color, that's yellow. What it means is that it has passed 90%. 90%. So it's up to you to want to stick with it or you continue. So when pile is negative, is in compression. When it's positive, is in what? In tension. And these values will be checked with the respective compression or tension limit. So when you even, by clicking here, okay, you can always see the F there, and this, you can also turn on the member forces. Sorry, you can turn on the pi forces to show you. So when you review any pi, immediately you see it there. So this enables you to make your quick decision. So say no, you want to change the value. You can note this down. See, you can note this down and check. You can also review by checking your load combination or even against your envelope. So you can check, review your contours and make all the necessary adjustments. Let me check something. Let me deactivate these pi forces so that so I want to deactivate the pi forces. It's taking okay, so that we will be able to review. So when you evaluate, like if we look at the required steel here local, and then the required steel, assuming a wood hammer is considered, which is your twisting, more or less, assuming you are observing it, it's always advisable to use because this value will always be higher than the AS1 because it's taking cognizance of the twisting effect. So when you do this, let's go back to the contours. Okay, so you have the opportunity to select, define your contours, what they represent, the reinforcement. When you are done with this, like here now, you can change this to Y12, and if you update, these are all based on your own design. You can also do automatic contours. You can check the threshold. What is the threshold between the minimum and the maximum values, which will also give you an idea of we are talking about, we are done with the piles now. So we are looking at, briefly look at the raft, the slab, which can be, you can follow the same way you design flat foundation, or even mat or raft foundation, flat slab, the same way to now do this. Okay, so when you are satisfied with this, we can close this. Then we'll go back from here to, we can decide to also review our pile capacity by going to the review tab, visual tab, click the visual tab. Then we have the pile, look for pile capacity. So this can also give you a quick overview. You can see, like this one now, 90%, 90% of the pile capacity, which may not be so encouraged. See, so these red ones are the ones that have failed, and you can easily just adjust this and review. So let's go to the plan view. Now, I want to do something quickly, even though it's more economical to use, especially for irregular shapes, it's more economical to use the contours to define your reinforcement. But here I want to use the strip, finite element strip. I want to quickly show you this on how to design your reinforcement for the slab. So you come here, sorry, let me take you back. Am I too fast? Go to the modeling tab, select slab strip, and then go to the foundation element. Depending on the type of raft, if it's raft with beams, we will use the span strip. But in this case, it is like flat plate. So we are going to be using a fixed band strip. And there are three methods actually. Here, of course, you can only, it's only FE flow analysis that is active. And there are only three types. And one is where your strip is maximum. Your strip, you can either do a strip that is maximum, and when it is maximum, the values of the transverse nodes at each stations are used in the calculation of the result. Meaning, if you are cutting a strip, you can do this before going to the post-processor too, but you can equally do this at any time. Insufficient depth, meaning our slab depth cannot pass. It will be too, the reinforcement will be too much, and even our punching shells, when you check, it may not pass. So it's already giving you an idea, like when you cut very close to, like here, no warning, but here just now, gave us warning. I'm going to explain how we do this. But because of that warning, let's check some of the loads you can see. So, but we can also, I will also explain something quickly. That when you are using the maximum, what it means, this strip takes the nodes, along the nodes, this width along the nodes, picks the maximum values and use it to design. It may not be economical. So what do we do? There's another method which is more economical. We can use the strip, and then after selecting the strip. Of course, this is end to end. Then we can select the scope width, and then we select integral. Integral within the width. I'm going to explain this too. So let's take a similar strip again. I said integral. It did not fail. This is because integral, what the integral does is to pick along this, pick the average, takes all the moments and then pick the average and spread the average of the moment and use it to design. So it's like an average result which yield more economical and smoothing values. But this method is only for fixed band. And then what this means is that don't let your scope to be too wide, because if it is too wide, it might not give you a true result. Because assuming you are having the range between your values, if there are too many, if it's much, the average may be lower than what is ideal. So ensure you keep your strip within a reasonable level, and this should be purely based on your engineering judgment. So when you do this, we also have a strip line, which is solely for checking purposes, and it does not account for anything, and that should take during your post-result analysis. It doesn't account for the result, but it only displays the values and also help you to check at the spot. So we are using the integral, and with this integral, you can select the range, or the other thing you can do is to select this from the end, select here, and update to take it to whatever strip you see this as change. So you can do this as close as possible, as much as is practicable. You can see, of course, it also needs to have boundary with this. So I'll press this again, select this, click. Now, the other thing is also advisable also to use one strip for similar thicknesses. So in a situation whereby you have different strips with different thicknesses, and I want to believe that one of these days we are going to be treating that too, where in order to make this to be more economical, we can come here and say, no, let the slab under this column to be a particular thickness. Maybe let's here to be 800 and then the other one to be 300. That can be very, very economical, but you cannot start drawing the same strip line. That will not yield the correct result. It will only take account of the first node you click and ignore the other ones. So always ensure you do this properly. So when you are done with this, I'm not going to do everything. This is just sample this now. Integral. We also select the edge and then we update. So when you do, you can see your reinforcement coming up, and at any point you can also run your strip design, which gives you the opportunity to adjust this value. Let's say you want to adjust the, you can also do this to also review. your moment. You can see to check against the different load cases. You can also do this to print, okay, to redesign or print a design report. Okay, this gives the reinforcement. I'm going to show you. Okay, so when you are good with all this, let's even check our design status and see. Okay, not until we are done with everything, we will not be able to see the status. Yeah, it's all the same. Because of time, we cannot check all this again. So when you are done, like I said before, you can go to your foundation design, run your foundation design. This will bring out, sorry, don't mind me. Sorry, slab analysis. Okay. So you can see it's telling you the type of integral, the type of strip you are using. Then you can redesign this using batch mode. And then you can filter, can do your setting again to say you want to change a particular value, but ensure it's not affecting your. Okay, so when you are done with this and you are satisfied with this, the next thing can see. The next thing after running design is telling us everything has passed, but please ensure you run everything. Okay, so when you are done with this, the next thing you are going to do is your report. And from this report, you can, sorry, not the general manager, but let's report manager, but let's look at it anyway. Because this is intended to group all your topics, all your headings for reports. But it may not show here if you have not run the report before. But because I've run post analysis check, these are all for superstructure, they're all appearing here. But for this case now, we can run, let's take our pre-analysis check, post-analysis check, strong column, join depending. This depends on the code you are using, the beam, but in this case, we're only dealing with foundation, your strip footing design, basis foundation report. Let's see. Let's see what our foundation report will give us. So from the foundation report, you can select what you want, add base pressure, add foundation, add require. So everything you want to be included in the report. If you are done punching checks, you'll be able to see based on the envelope, you can select all and then generate report. It might take time, but let's wait, let's observe and see. It's running. It's taking this time because of all the options selected. So ensure you are definite about what you want. I could have selected one of these, maybe the 1 + 4G + 1.6. And then all this add notification summary to the report, FE floor analysis report, app-based pressure, and all this. They may not be necessary because they could take all the time, but when you are submitting the final report, you can always do that. And while we are waiting, like I told you before, if they are failed piles, you can either increase the pile compression or increase the number of piles, or even both. You can also increase the thickness of the raft, but all this will also have their own effects. Now, our report has been generated. It will open automatically. So wait, just hold on while it opens. Please beware not to select whatever you don't need here. It's been processed. It's going to open. So that we'll have the opportunity of reviewing the report, and then we'll continue. Very good. Writing the report now. Can see? So this report will give you the mat foundation properties. Can see? Then the column combinations. See the reason why it took a lot of time. Telling us that available base pressure exceeds maximum base. I hope you will not be surprised because what we did, we ignored all the warning, and so the report will also include your layout. And see, this you may choose not to include. Overall, we have almost 496 pages. So this report will also show your contours, assuming you work on the contours to show and see. All the reaction based on each load cases. Load Q, we should have chosen maybe a load combination alone. Can see, gives you the load distribution, the moment. Okay. So when you are done with your Raft design and your reports and you are satisfied, everything is good. In conclusion, as a structural engineer or engineering firm, one smart decision you can always make and never be wrong is to invest in ProtaStructure Suite 2022. The one for full modeling, analysis, design, detailing, component design, drafting, fabrication, and BIM. You can always combine. If you are elsewhere other than Nigeria, you can contact Global Sales at ProtaSoftware. Even if you are in Nigeria, you can contact this, and then if you are in Nigeria, you can always reach me directly through this for your inquiry. So thank you. If you have any question, please, you can forward all your questions to either you put them on the text chat, include your email, and then we'll get back to you as much as possible. Or you can also visit the website as displayed. The website displayed can visit ProtaSoftware.com for other inquiries. Thank you very much for participating once again today. Don't waste another opportunity. Thank you.